Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico series, lessons 25 through 28. In these lessons, we're going to be connecting up the OLED display to our Pi Pico and doing some fun things with it, and then expanding it by connecting it to the network. So I think we're going to have a fun lesson, so let's dig in. First, I want to take a look at my hardware configuration. So I have my 128 by 64 OLED connected up to my Raspberry Pi Pico, which is out of frame, but I had to zoom it in so you can see the display clearly. And so for lesson 25, we're just going to connect this up and get it working. And oh, looks like we have an urgent message from Little Orphan Annie. Be sure to drink your Ovaltine. And though this isn't a lot going on, this is obviously testing that all the pins are connected and working and that everything is functional. Now in lessons 25 and 26, our homework was to create circles and Lejeune figures, and I decided to sit those out because I didn't want to deal with the trigonometry. I would rather work on hardware and get this kind of stuff working. So I will admit I sat those ones out, and I will be getting an incomplete for the course, but that's okay. There's a lot of forgiveness in the world of Top Tech Boy. So now that have this message displayed, one thing I noticed is that if I just went and stopped the program at this point, the display would not clear. It would just keep showing this message. So I actually put a exit function. I'm going to press this push button up here, and we can see that we have a little goodbye sequence. And now not only does it stop the program, but it clears the screen before it does. So now it's obviously ready for the next program. Now to go a step further, in lesson 28 and 29, we connected our Picos to the network and we started sending it commands. So let's go ahead and do that. I'm going to start this program and we're going to see we are connecting to the network. And we have an IP address, 10.20.20.201. Remember that 201 because that will be important later in this lesson. And you can see it says it's ready. And the reason I put that little prompt in there is I want to know when the Pico is done doing other things and it's now waiting for commands from our client application. And I'm going to start up my client application over here, and I'm going to switch views here so you can kind of see what's going on. So here I have my desk view where you can view the OLED screen, and then you probably can't see it well, but my command window up in the upper right. And so now I can start to send things to it. So let's say I just want to send some text. I'm going to send hello, how are you? And you can see I can send text that way. I can just send an empty character to clear the screen. But now I can start to actually build out command structures. I can think of things that, what are commands I want to send to my Pico and actually make it do things. Like for instance, what if I wanted to turn on an LED? That would be kind of fun, huh? Turn the LED on and off. What if I want to draw a circle? I could send a circle command and it would respond by drawing a circle. Now, I will say this, I already said I've skipped lesson 25 and 26. Yes, that is borrowed code. It's not my code. I just wanted to put this in here just to demonstrate the command structure. The command structure is mine. Some of the code, maybe not. When we get to the code, I'll show you. Now, of course, we all want to do the spinning Lejeune figure. And I had a command called Lejeune, but the problem is that the text of the word Lejeune ran right off the edge of the screen and covered up my Lejeune figure. So I wanted to just make a shorter command called SPC, or spinning potato chip. And so here we have a spinning potato chip. And unlike the other spinning potato chip program where it just looped forever, this one has a counter attached to it, so it'll only spin for so long. But this is why the ready prompt is so important. I need to know when it has stopped running its code, whether it's drawing the circle or the spinning Lejeune figure, and it's ready for the next command. Because if I type a command before it's ready, that command will basically just go into empty space and never be received by anything. Now, of course, I again want to have a proper shutdown command. So I'm going to type goodbye, and It's going to start the shutdown sequence, and now the program has stopped, the display is cleared, and we're ready to run the next program. Now the next assignment in lesson number 28 was to take what I just did but make it portable. Connect up the battery, disconnect it from, in this case, my Raspberry Pi as my computer, and have it run completely autonomously. And so in order to do that, I need to pause the video really quick, and I will be right back with you. And I'm back. Let's take a look at what I've done here. So I've taken my Geek Pi portable kit, the one I made Charlotte buy, I guess, and well, she says so anyway. You can decide for yourself. But I've taken my Geek Pi platform along with my uh, Extra Pi Pico W, or one of them, and I do want to show this. I've talked about this before, but I want to show this again. So when you buy the Picos, they don't generally come with pins pre-soldered. I have seen now some Pico WHs out there, but they're very, very rare and hard to get. So you have to solder the pins on. Instead of using the standard breadboard pins, I used these, what are called stacking headers. And the idea of the stacking header is you have the long pin on one side, and then you have female pins on the other. The idea is you're building boards that stack onto each other, so you can kind of like a shield on an Arduino, you can kind of stack them in. Well, I prefer using female headers as opposed to male headers, because then you can use male-to-male jumpers a lot easier. So I have my one of my other Picos is soldered on with these stacking headers, and it just makes it easier because when I plug it into the socket on the Geek Pi board, I have the option of either using the male headers that are on the Geek Pi board, or I can use the female sockets on the Pico itself. So I have that flexibility, and I really like that. So here I've got the battery of the Sunfounder kit connected up. And I'm going to tell you right now, I don't like how this works because you have to disconnect and reconnect either here in the connector or the pins on the board. And I'm really concerned about that because if I'm in a hurry, it's very likely that I could plug it into the wrong pins or that I could damage this connector or something. And so I have plans in place. I'm going to try to implement a toggle switch into this so that I can wire it up once, leave it connected, and then just toggle it on and off. I think that's going to be a better result. So the screen is a little bit blurry. Let me see if I can't focus the camera any better than it's already focused, but maybe I can get a little better viewing. We'll see. It's hard to see, but the IP address that we're seeing here is actually .202. And if you remember, the other Pico was 201. Yeah, it's not going to be quite readable no matter what I do with it, so you'll just have to bear with me. But just trust me, that is a value of 202. So I have DHCP reservations. The Sunfounder kit Pico is 201. The Geek Pi Pico is 202. And one of the reasons that's important is because when I'm using my client application, which I'll pull up here in a second, I need to know whether or not I'm sending a command to the Sunfounder Pico of 201 or to the Geek Pi Pico of 202. So I'm going to say GP for Geek Pi, hello, and we'll start sending it commands. How are you? And now we can do, again, Geek Pi circle. So I'll run that command once again, and we'll draw the circle. And you'll notice this is a slightly different OLED. This is the one that came in the Geek Pi kit. So the rather than having the yellow and blue, it's just a single color, basically white on black or off-white on black, if that's more accurate. And I can turn an LED on. Oops, I forgot to preface it with Geek Pi. That matters. If you don't preface it with this multifunction client, nothing happens. There we go. I can turn LED 1 on. I can turn all the LEDs on if, again, I preface it with. And then I can let's turn LED 3 off. and LED 2 off. And how about we just turn them all off? And so there we go. So we've got our portable Geek Pi running on battery, completely disconnected from a computer, receiving commands over UDP to turn LEDs on and off. And of course, the last piece of the lesson was to control an RGB LED. So I created an RGB function, and I'm going to say Geek Pi RGB red to turn on the red LED, and Geek Pi, Greek Pi. What's a Greek Pi? That sounds good. Let's go RGB green and Geek Pi RGB blue. And then if I want to turn it off, I just send it basically an empty command. Just like that. And once again, we do our Geek Pi goodbye. And I'm going to shut that down. All right, so that's enough for the hardware. Let's go back and start to look at the software. And there we go. Okay. So pretty straightforward. This is our first program where we just displayed a message, and I'm just importing, the necessary tools. I've got my I2C and my SSD 1306 library, and I have this running flag because this is what I use when I exit the program, whether it's the push button or the goodbye command. I'm just going to set this running flag from 1 to 0. And then you'll see below I've got a loop that's looking for the running command. And when the running command hits something other than 1, it just shuts down. And so I'm setting up my my I2C bus to get the display up and running, 1306 using the I2C bus. I've got my message defined with my X and Y coordinates for each row. And don't forget the dsp.show. I can't count the number of times when I was developing that I would set all of this information and then forget to send the show command and wonder why my display isn't showing what I told it to show. And so here we go. So now we've got this while running is 1. So while the program is running, we're just going to sit in a loop. I'm going to read the button state. This is all code I've shown before where I basically just I press the button, and then when I release the button, it actually continues with the whatever that action code is. And then I've got my goodbye sequence. So I clear the screen, write goodbye, sleep 2 seconds, and then set the flag to 0, which then shuts down the program. So pretty straightforward. Now, of course, as you can imagine, the Wi-Fi server program. Actually, before I do that, let's look at the Wi-Fi client. Because generally speaking, when we're doing client-server type projects, you want to put the validation on the server side. There's a well-known set of vulnerabilities out there called cross-site scripting vulnerabilities. Maybe you've seen that in various patch notes and so forth. Well, what is a cross-site scripting vulnerability? Basically, what it's doing is it's looking at the client that has been given to you that you're supposed to use, but by modifying the client, we can start to send bad data to the server, and because all the validation is on the client side, the server will accept it. So that's just generally bad design. So we want to keep the client as minimal as possible. We just want to take the client and say, whatever the user enters, we're just going to literally pass it. And then the server is going to decide what do we do with that information. That way, if somebody, if I had a bad actor on this network that was trying to use their own client, it wouldn't do anything differently because I'm just sending literal commands anyway. So I'm just doing my socket, the set IP. So obviously the simpler version of the client is just connecting to the Sunfounder Pico at .201. And we're just going to come down here. So I do have, with the client, I have an exit command. So actually it's still running. If I come down here and I just type exit, that exits out the client. So this is what, basically anytime the command is exit, we're just going to exit the program. So this is really the crux of the program right here is this input command. So I have this nice little command prompt written here to make it a little fancier than just, a question or whatever. I think it looks better. But it's important to note that when we do this input, it stops the program flow until the user enters something. Um, I'll explain to you why that's important, but basically right now the program flow is stopped on this command. Then when the user enters something, we evaluate what is it. So if it's exit, um, or if it's not exit, I should say. If it's not exit, that means we're sending the command straight to the Pico, and we're just going to encode it and send it. So this is really the crux of the client command right here, is we're just taking the literal whatever the user sent us and pass it on to the Pico. Now we're going to go to the more advanced client, which is the one that supports 2 Picos. So I've got my 201 and my 202, and I basically got 2 sets of all of this information. And again, looking for that exit command. If the command isn't exit, let's forward it on. So I'm using this command called split, or I should say a string method called split. So I'm taking CMD as my string, and then I'm using a split function, and I'm looking for the first comma. So this is where I type SF comma command or GP comma command. And what I'm interested in is it SF or GP? And this one means that I'm only evaluating the first comma. So let's say I would send it a value. For instance, I was thinking about sending RGB values, which are going to be comma separated. So I need to make sure that those commas are carried forward and that the client's not going to try to interpret them. It's just going to send the literal commas to the server application. And so it's just deciding whether it's SF or GP, which one is it going to send it to, and then it sends the command. So you can see the client, there's really not much to it because, again, you want all your validation to happen on the server side. So let's go to the server program, which is really the big piece of the software here. So bringing in all of these different um, modules. I'm bringing in PWM so I can control the RGB LED as well. There was a point where I wanted to put in RGB values, so that RGB function I used in the client, where instead of sending a color name, I would send an RGB value in comma delimited format. And basically what happened is I just ran out of time. Every function I wanted to implement that I didn't implement just took too much time, and I do want to talk about that a little bit. I know this video is getting long. I'll try to keep it short, but I did a video some time ago on the idea between ambition and curiosity. And when I connected this Pico to Wi-Fi, suddenly that curiosity alarm just went off, and I just had tons and tons and tons of ideas. And I had to just say no at some point because I had to get this assignment done and this video recorded, and I'm already like 2 weeks late on it. The reason this thing is so late is because I was having so much fun, and I wanted to do this, and I wanted to do this, and I wanted to do this, and the list just goes on and on. Oh, sorry about that. Let's try that. There we go. And then I'm using a secrets file. I didn't go through the full uh, Python compile that Charlotte talked about. Charlotte did a really nice job. I'll link to her video below in terms of using a compiled program so that if somebody stole your Pico, they wouldn't have your network credentials because it's actually compiled, and that's really cool. And then this is all the kind of stuff you've seen before. We're just setting up our PWMs, setting up our output LED pins, etc. Now we're setting up I2C bus and setting up the display to use it. Now we're going to get into all of the wireless configuration. So I want to make a point. This network WLAN function, there is a fantastic document on this function that I will link below. And it talks about all the different methods you can pass it. One of the functions is scan, which I know somebody was asking about building a Wi-Fi scanner with their Pico, and yes, you can do that. But the thing I really wanted to point out, because I know it's affected, I know it's affecting a lot of people, is if you're running and testing the program over and over and over, eventually you're going to hit a point where it just won't connect to the Wi-Fi anymore, and you have to take that USB connector and unplug it and replug it to power cycle the Pico to get it to clear. We can get around that by using the disconnect method. So every time I run the program, it checks and says, is it connected? Because we don't really do a disconnect on exit. So is it connected from last time? And if so, we're going to actually disconnect. And that's how every single time I run the program, it does that little connecting line because it's actually disconnected and now it's going to force reconnect. This has saved me from ever having to unplug and replug. And again, I'm going to link that document below because it was very helpful. There's a lot of neat stuff in there. And so now we go through our connect. I'm pulling from secrets my SSID and password. And we're just going to do this kind of little blinking text while we're waiting for it to connect. And once it's connected, we'll grab the IP, display it, and set up our, oh, where is it? Okay, this is just bringing things up here, getting the port set and everything. Then we actually get into this ready state where we write out connected the IP, that ready line, and then we're going to stop right here. So this line right here, this received from buffer, again, this stops program flow. And the reason I wanted to bring this up is because in the client, we have this line here. Sorry, try to highlight that better. With this line here that stops program flow. Program cannot continue. I can't read sensors. I can't write LEDs. I can't do anything because program flow is stopped waiting for keyboard input. In the same way, this line stops the server program from accepting any input. I can't use push buttons. I can't blink LEDs. I can't do anything because the program flow is completely stopped. And the reason that became an issue is I was thinking about different ideas. One of the ideas was since I have two Picos and they both have different IP addresses, why not make them talk to each other? Why not make them send commands back and forth? Maybe I can put a push button over here that blinks an LED over here, and I can put a temperature sensor over here that displays over here. And the problem I ran into is in order to do that, the Picos have to be sitting and waiting for commands from the other Pico, which means they can't be reading sensors, they can't be reading inputs, they can't be displaying LEDs. The only way we could do this is doing multi-threading on the Pico. Now I'm confident we will get there. I think we will get to a point where we can do multi-threading, so I can have a thread on one side that's listening on the UDP stack to say what is my incoming command, and then have another thread that is reading sensors and sending data to the other Pico. We will get there, but for this lesson, it was just too much. But I wanted to point out the reason it's difficult is because in both cases, whether it's the client or the server, we actually have to stop program flow and wait for input. And while we're doing that, we can't do anything else. Now I get into my command structure. So I just look at, the first thing is just all my LED ons and LED offs, because those are just digital on, off, nothing too fancy there. Then the circle, yes, this is stolen code. This is right off of Paul's page. So this is stolen code. I'm not even going to pretend it's mine. That's circle code that other people wrote. Again, the spinning potato chip command, it's not that I'm lazy and didn't want to type Lejeune or didn't want to spell Lejeune. It's just that the word got too long on the screen. So I use spinning potato chip. Again, this is code right off of Paul's page. I'm not even going to pretend it's mine. Now we get down to the RGB function. So I'm passing RGB, and now we're going to evaluate it. And we're using, again, the split function now to look inside the parentheses. So I have an open parentheses, a closed parenthesis. Let's just grab whatever that is and evaluate it. And you can see what I'm doing here is I'm using RGB values in a list. Again, it would be easy to send RGB values, comma delimited values to the server Pico and display that on the LED. I just decided in the interest of time, this program is not going to do that. But you can see everything is done via RGB. So red, green, blue, I'm setting the RGB values, printing the RGB values to the screen, and then doing all of my RGB math. Again, I'm doing the logarithmic outputs, etc. So this code I think will show up in a future lesson. It's just too much for this one. And then I have my goodbye command where I shut off all the LEDs, set my PWM duty cycles to 0, display the message, and set running to 0 to exit the program. So I know this video got long, but the reason is because I tried to cram so much into one video. I didn't want to split videos because that didn't go well the last time I did that. And I'd rather just create one video, get all my homework done. Now I can start with lesson 30 and 31, actually connecting it to the internet and pulling data down. So hope you enjoyed this video. If you did, be sure to hit like and subscribe below. I'm going to drop those links as well to Charlotte's video as well as the WLAN document, and I will see you next time for Simply Brian Enterprises. This is Brian. Thank you for watching.